closed contact operating possibly another motor. We'll call this motor 2. This is just a made-up schematic. It's very possible. Notice that when this coil is energized, this one would close, this one would open. Switches, contacts are called either normally open or normally closed. They change their position when they're energized. Schematics under normal procedures are drawn in de-energized positions. Now, I didn't say normally closed and normally open on the contacts, did I? So if I'm drawing this and I'm drawing it as the usual procedure, I'm going to show the state of the contact as it would be in a de-energized position. So there are exceptions to that. When you have a schematic that is showing the operation, sometimes they'll be drawn in an energized position, but it should be noted on that schematic that it is in the energized position. Did you have a question? Oh, okay. Sorry. All right. Something I like to do is I like to show where connections are with a dot. Okay? Now, is that absolutely necessary? No. There are some standards that, one in particular, is you could have two lines crossing one another. Now, here's my question to you. Is that connected or not?
It's connected.
It could be, but it may not be. Depends upon how someone has drawn it. In order to keep that confusion from happening, what I like to do is if I have a line or wire going over and not connected to the other one, I like to put that little loop there. There's no question about it. If I have the dot, shows it's connected. If I have the loop, it's not connected. There's no question about whether this one's connected or not. Okay? Whereas one going across like that would not be connected. Okay? Not all people do that. But I found out that it's a whole lot less confusing if I'll use that particular thing. All right, we're going to move into another part, and we're going to try to solve a problem. And our problem is going to be actually drawing a schematic of a small unit. We're going to be using a window unit. This window unit is going to be a line voltage window unit with all the controls using line voltage controls. The unit is going to have a system switch and a thermostat. Now, the fan motor is to operate at all times. Most window units, how many fan motors do they have? One. It's a double shafted motor that would operate both the blower for the evaporator and the fan for the condenser. Okay? All right, first thing we want to do is we have L1 and the neutral. We're going to say that this unit is 120 volts. Okay? We'll show the 120 volts from each side there. Okay? We're going to use a PSC motor. Now, I don't know that you're up to that yet, but a PSC motor is called a permanent split capacitor motor. Now, being that I said that it's a permanent split capacitor motor, I need to show the windings and the capacitor, which we didn't do a symbol for capacitors yet, but we're about to. I maybe have drawn that a little small for you, but that's going to be a run capacitor. Okay? That is a PSC motor. I'm actually showing the start windings, the run windings, and the common terminal on there. All right. Now, we're going to call this our fan motor. We're also going to have a compressor. Our compressor will use the same type of motor, being a PSC motor, which uses a run capacitor. And here we have C, S, and R also. This is our compressor. Okay? Now, y'all remember parallel series circuits? In order to have both of these components to operate at the same time, do they need to be in parallel or series?
Series.
Parallel. Sorry. Parallel. There we go. Now, when drawing schematics, to me, one of the most important parts of the tools is the eraser. So if you draw this in ink, you're going to have a hard time going back and making corrections. But if you got that eraser, you can always correct any mistakes without it being confusing in the future. Because when you start trying to blot out stuff on schematics, it just makes more confusion. Now, I asked for a system switch, and that's what this is going to be. That's going to be our system switch. Now, if I connect that system switch to both components, there would be no temperature control. But I need a temperature control of some type. Here's where the eraser comes in. Remember, we said the fan motor was going to run any time that the system switch was on. I turned this on, that's going to run. But in order for the compressor to cycle, I am going to have a thermostat. And there is the symbol for a thermostat. Okay, maybe not exactly right. Temperature goes up, it closes the contact, cuts the compressor on. When temperature is satisfied, the contact would open up the thermostat and de-energize the compressor. The fan motor would be on any time that the system switch is on. We just actually done one of your labs, one of your schematics. So you'll see this coming up. Now, when it comes to pressure switches and thermostats, I've heard people call them, is that a cooling thermostat, or is that a heating thermostat, or is that a high pressure switch, or is that a low pressure switch? That can be quite confusing, because in some times you may actually have a thermostat that serves a purpose not exactly for cooling or heating. It's still going to measure the temperature, but it may not be doing what you would think as a normal thermostat. Same thing with pressure switches. You may have a pressure switch that operates a condenser fan motor. Well, it's going to come on the high when the pressure goes up on the high side, whereas normally a high pressure switch is going to open in case the pressure goes too high as an emergency or as a safety switch. So how do you tell one from the other? Use terms called close on rise or open on rise, either way. Or you can reverse that and say close on fall or open on fall. Then it's specific on what that switch does.
Is a symbol for that?
A pressure switch?
I mean, the phrase you just used.
Usually it's the way it's drawn.
Each one of those phrases?
Right. It's usually the way it's drawn. Okay? For example, if this were a thermostat, okay, then you can see as the temperature goes up, the switch would open. So it would be open on rise.
So that indicates open on rise.
Right. If I had it drawn like this, then it would close on rise. And I could change my wording and call it I said opens on rise. I could call it closes on fall. Okay, this one would just the opposite. I made myself
but that's a real. If I was reading the schematic, that's a real symbol that I would recognize.
That's a real symbol. Pressure switches are going to look like so. Okay. Usually time delay relays are going to look more like that.
Foreign language again.
Well, it's like anything else. You have to get accustomed to seeing it.
So both those last two signs are exactly the same, except one's point down and one's point up.
Yeah. And it depends on where the switch position is.
So that inverted V is a time relay?
Yeah, that's a time. That's the normal symbol for a time delay relay.
Time delay.
Dave, why you come up with this?
You know, that's one thing about it, we make it up as we go, right?
Do you agree with this? Yeah, go ahead and ride with it.
Bottom one is what?
Okay, this would be a thermostat, this is a thermostat, pressure switch, time delay relay. And like I said, refer to the legends, or look at the book, some of the symbols as in some of the handouts, things such as that. You're gonna see different variation of the way they're drawn. Okay, we got any questions? I think we're gonna about conclude
That's the
this.
most common one, though, right?
It's the one that I'm used to seeing, okay? And is it most common?
No.
I can't say that because different manufacturers will use variations in their symbols. But it's just the same. You should be able to, if you can read one, you should be able to read the other. Okay. Anything else, Jeff?